Hello friends, welcome to TechCube Gate classes. My name is Vivek Singh Rathore and I am teaching you signals and systems. In the previous lecture, we have discussed on various type of elementary signals, how they are mathematically, graphically represented, and we have completed almost over 7 type of signals which are basic. And now, from in the today's lecture, I will be taking how to do basic operations on these signals. So let's get started on basic operations on these type of signals. Basic operations. So first we'll be seeing time shifting operation. Time shifting. So what is actually time shifting and how we do it? So see, the name suggests time shifting means in time domain we are shifting a signal to either, I think if I tell you from this domain, so either we are shifting towards right hand side or towards left hand side. These two are the most possible chances which we can shift. So what we are doing actually, if signal is ft, okay, signal is shown by ft, so if we are doing shifting in the right hand side direction, we are actually delaying the signal. Okay, so here it is represented as ft minus of let's suppose it is shifted by t naught time, so ft will be ft minus t naught. Okay, and if we are shifting in this direction, let's suppose by t naught time. Okay, so now for this shifting we represent it as ft plus t naught. This is called as advance and this is called as delay. Okay, so this ft minus t naught will be called as delayed signal and this is called as advanced signal. Okay, so uh, let's take some example and try to understand it. Let's see, one signal is there. Okay, and this signal, uh, let our signal rectangular pulse is there and this is minus 1 to 1. Okay, and magnitude is 1 and this is represented as ft. Now if anyone says you that you need to shift it towards ft plus 3, ft plus 3, this you need to do shifting. So what you are going to understand from this portion is it is actually advanced. This signal is advanced by how much quantity? 3. So now if you want to do mathematically, you can equate this portion with 0. So t plus 3 is equal to 0. So you'll get how much you need to shift is t is minus 3. So just do simple thing, you need to add up with this value, whatever this value is there you need to add with this. So all values, so 1 is there, 1 plus of minus 3, minus 1 plus minus 3, so you'll get 1 minus 3 is minus 2 and 1 minus 1 minus 3 is minus 4. So actually this signal now became like this. This is minus 4 to minus 2 and magnitude will remain the same. So now you can understand this ft is there, ft is this and ft plus 3 is this. The same signal was there, you have just shifted it to the left hand side or you have advanced the signal. Now if anyone says you that you need to do ft minus 3, the same ft minus 3 of same signal. So now what you will do, t minus 3 you will equate it with 0. Okay, so t minus 3 will equate with 0, you will get t is equal to plus 3. So you need, what I have told you, just you need to add whatever value comes here. So 1 plus 3 and minus 1 plus 3, you will get answer as minus 1 plus 3 is plus 2, 1 plus 3 is plus 4. So now the signal will be your this one and the value will be 2, from 2 to 4 the magnitude will remain same. So this signal ft minus 3 will be same this. So I think now you can understand time shifting property. What it does represent is you need to shift towards left or towards right. Okay. Okay, I think this you have understood. Now we'll move on with the second portion. Second portion is time scaling. time scaling property. Time scaling is actually we are going to scale it. Scale means in Hindi will खींचना will or दबाना something. We need to change the magnitude or not magnitude of actually time domain, that we need to change it. That is called actually scaling. So let's suppose, see, ft is signal is there, okay, ft signal, some signal is there. Let's suppose we will take our rectangular pulse only -1 to 1. This is our ft. Now you need to scale it. So scale means for scaling time domain, we need to do here multiply with a. Now a can be either greater than 1 or less than 1. Maybe a is greater than 1 or maybe a is less than 1. Okay, let's suppose here we do f of half t or f of 2t. You can understand what I am telling you. A can be greater than 1 or a can be less than 1. If you see a is greater than 1, okay, a is greater than 1, you can understand that this is a property of compression. Means the signal, if you see f80 and a is greater than 1, you can understand that whatever the signal was in ft, it will be compressed in f80. And if a is less than 1, you will get to know that it is expanded. Expansion will take place. Okay, let's see how. First of all, you need to understand how we do it. So f80 is there. Whenever you need to calculate, let's suppose f2t is there, okay, so whatever a will be there here, you just need to divide that a with this. So here one value is there in denominator, you can put a, okay, -1 by a. Whatever the values will be there, you just need to divide with a. Okay, you will get the answer. Like, let's see, I need to calculate two values. Let f2t I need to calculate, and here f half t I need to calculate of this signal only, which we have drawn here -1 to 1. Okay, here I'll redraw it -1 to 1 and magnitude is 1. This was our ft. Now we need to calculate. So see, f2t. For f2t, I told you whatever a may be there, you need to divide it. So we'll do it divide. So the value comes here minus half to half. You can, and magnitude will remain same. So you can understand that our signal was -1 to 1 and now it is from minus half to half. Actually this signal has been compressed. Okay, and if you see this signal f half t, okay, I will do it. I think again I will plot here signal -1 to 1, and for half t I told you that whatever a will be there, you just need to divide. So 1 by half and -1 by half, this will go up, this will go up, and this value will be there minus 2, say 2, and magnitude will remain 1. So you will get to know that this signal which was earlier -1 to 1, it is now -2 to 2. So this signal has been expanded. So that what I was saying, that whenever we do time scaling, so we need to see a is greater than 1 or a is less than 1, and we can understand that this operation will compress the signal or it will expand the signal. Okay, now we'll go to the third section of our basic operations, that is called as time scaling property. Time scaling property. Time scaling, not time scaling, I think time scaling I have done. Time reversal property. Okay, time reversal property. So time reversal property, see, now the name suggests time reversal means we need to reverse it in time domain. So what we can do, this was the value t is equal to 0 and some signal was there, maybe this signal was there. Okay, I think this signal was there. So if you do time reversal, just mirror image you need to calculate. Actually this is in the time reversal, so reverse it. So whatever was there, we need to do like this, and this is called as this. If this was ft, this will be f of minus t. Just you have shifted or reversed in time domain. So this is called as time reversal signal, time reversal operation. Okay, so just what you have done rotation of 180 degree across y-axis, or just you have done adding extra minus sign to every value. Like see here, the value was from 1 to 2, let's suppose. So what you have done just multiply with minus sign to all, and just shifted here. So the value will be from here minus 2 to minus 1, because this value have been shifted this side. So this will be minus 2, and this will be this side, so this will be minus 1. So from this you can understand that how we can do time reversal property. Now I'll tell you one example, and one or two example. From there we can understand how we can do over some signals. So seeing one question I am taking from sawtooth pulse, because seeing sawtooth pulse you can understand the property of time reversal also. Sawtooth pulse, if you see, it is represented as like, see, it is represented as like this and like this. In this sawtooth pulse you can see both unit step also and unit ramp also. So these values are, let's suppose this value is 2 and this value is 3, and the magnitude is 1. This is our FT signal. Now you need to calculate, question is, you need to calculate, if this is FT, then just calculate f of minus t minus 4. Okay, this you need to calculate. So how we can do it? Okay, so I think this, first of all, whenever we do this type of operations, first you need to do time shifting. Okay, because anyway you can do from other method also, but that will leave you with lot of steps. So for shorter tricks you can prefer first time shifting. Okay, then you can go for time reversal or time scaling, anyway you can do, but first you need to do time shifting. So first step will be ft minus 4. First step, you need to plot ft minus 4. So I have told you while time shifting that if t minus 4 is there, you need to do minus t minus 4 is equal to 0. So t is equal to plus 4. Hai? So you need to just add whatever value is there. So 3 plus 4 will be, and 2 plus 4 will be. So this will be value, like I have plotted this value, and now new value will be 6 to 7, and magnitude will remain the same. Okay. Now second step you need to do is f of minus t minus 4. Now f of t minus 4 has come here. Just what you're doing minus sign of this, means you are doing a time reversal property. So time reversal, you know that what we need to do is just we need to take a mirror image of that signal. Okay, and adding extra negative value. So here it will come negative value, here it will come negative value, and this will be shifted here. Okay, so I think this will be there, and this will be there. Okay, this will be our value, and this minus 7 will come from here, and minus 6 will be there. So your value f of minus t minus 4 value has been arrived here. So now you can understand that our property which or operation which we have studied here, how we need to apply on this. This can be done by other method also, like first you can do time reversal also, and then you can do time shifting also, but that will take you some other calculations also. So no need to worry, just first do time shifting and then you can do time scaling or whatever you want to do. Let's see second question also, and this will tell you more about scaling also. So let's do that same signal is there, our time sawtooth signal is there, sawtooth signal, and this signal value is 2 to 3. Let's suppose the value is 1, and you need to, if this is ft, then you need to calculate f 2t minus 6, let's suppose. Now how we can do it? I told you for whether it is scaling is there, whether reversal is there, first you need to do is you need to calculate shifting property. So ft minus 6 you need to plot. So ft minus 6 means you need ft minus 6, t minus 6 you need to equate with 0, t is equal to 6. You need to add with 6 value. So I think you can get the value as 2 plus 6 8, 6 plus 3 9. So this is the value which you get ft minus 6. Now second step, what you can do, f of 2t minus 6 also you can do. So t minus 6 you have plotted, just what you are doing, just you are scaling it with 2. So I told you while teaching that whatever the scaling factor is there, you need to divide it. So just divide it by the scaling factor, 2 is there. So next step, if you see, if you can plot it, you will get it the same value, and the value is 8 by 2 is 4, 9 by 2 is 4.5, and the magnitude will remain the same. So I think you could understand, you will understand that how we are doing our time shifting, time scaling, and I think reversal also I have told you with this example. So all the three operations I have explained you briefly. Now I think you can solve many questions from this, and you can get good answers. And if you are unable, if you feel unable to solve, then please do comment in the comment section and tell us what difficulties you are facing. We'll try to sort it out. Okay. Till then, tata, bye bye, see you, have a good day.